There are many different methods for graphing a line. The method we choose depends on how the equation of the line is presented. We will consider lines in slope-intercept form, point-slope form, and standard form. This resource will look at the method for graphing a line in each of these forms, and will provide multiple examples for each. Recall that the slope-intercept form for the equation of a line is y equals mx plus b, where m is the slope and b is the y-intercept. This is a very good form to use for graphing lines. How exactly does this work? We plot the y-intercept, which is where the line will cross the y-axis. Moving from the y-intercept, we use the slope to find another point on the line. We connect the points we plotted, drawing our line. It is important to remember to label the line, so write the equation near the line we drew. How exactly do we use the slope to find another point? Well, it depends. Recall that the slope is a ratio of the change in y over the change in x. So long as the slope is written as a fraction, we have the number of spaces we need to move up or down, and left or right. If the slope is positive, we can move up and to the right, or down and to the left. If the slope is negative, we move up and left, or down and right. Let's see some examples. Suppose we want to graph the line y equals 2/3 x plus 4. First, we need to plot the y-intercept. Looking at the equation, we see a plus 4 at the end. This means our y-intercept is positive 4. So we make a dot at positive 4 on the y vertical axis. Now we will use our slope to find another point on the line. We will use our slope to count from the y-intercept and plot another point. Because our slope is a positive 2/3, we can either move up 2 and to the right 3, or down 2 and 3 to the left. We choose to move up and right and draw the dot. We connect the dots, filling the entire graph with our line. Finally, we label our line with its equation. Let's see another example. Suppose this time we want to graph y equals 5/4 x minus 2. When we look at this equation, we see minus 2 at the end. Our y-intercept is negative 2. Our slope is positive, so we count up 5 and right 4 from the y-intercept to plot our second point. Connect the dots and label. Now let's see an example where the slope is negative. What if we want to graph the line y equals negative 2/5 x plus 3? The plus 3 at the end of the equation means our y-intercept is positive 3. Our slope is negative. We have the option of moving down 2 and right 5 spaces from the y-intercept, or up 2 and left 5 spaces. We choose the former. Connect the points and label the line. Let's look at one more example. Suppose we want to graph the line y equals negative 3/2 x minus 1. Our y-intercept is negative 1, thanks to the minus 1 in the equation. We move down 3 and right 2 spaces to plot our second point, since our slope is negative. Connect the points and label the line. But what happens if our line is in a different equation form? Another form for the equation of a line is the point-slope form. In this format, we know the coordinates for a point on the line and the slope of the line. Suppose we have the slope m and the point x sub 1, y sub 1. Then the point-slope form looks like y minus y sub 1 equals m multiplied by the quantity x minus x sub 1. How do we graph a line given in this form? The technique is almost identical to that we use to graph a line in slope-intercept form. First, we need to identify the coordinates of the point. Remember that there are minus signs built into the equation, so we need to change the signs. We plot the point we are given. Use the slope to find a second point on the line. We use the same method for moving up or down and left or right depending on whether the slope is positive or negative as before. Connect the points and label the graph. Let's see some examples. Suppose we have the equation y minus 3 equal to 4/5 of the quantity x plus 1. First, we need to identify the point on the line that is part of the point-slope equation. Since there are minus signs built into the equation, we need to switch the signs we see. Our line contains the point -1, 3. We plot that point. Now we use the slope to find our next point. We move up 4 and 5 to the right of our first point. We connect the points and label the line. Let's see one more example. What if we want to graph the line with the equation y plus 2 equals -2/7 the quantity x minus 4? We realize our line contains the point 4, -2. We plot that point. We use the slope to get another point. In order to stay on the graph, we move up 2 spaces and left 7 to plot our next point. Connect the points and label the graph. The last form for the equation of a line is the standard form. This looks like ax plus by equals c, where the a, b, and c are all integers. When graphing a line in this format, we have a couple of options. We could do some algebraic manipulation and transform the equation into slope-intercept form. However, there is an easier method. All we need to graph a line are 2 points. What if we could find those 2 points relatively easily? Well, we can. We will find the x-intercept and the y-intercept, or where the line crosses the x-axis and y-axis. We plot the 2 intercepts, connect the points, and label the line. But how exactly do we find those intercepts? We plug 0 in for the other variable and solve. Let's see a couple of examples. Suppose we want to graph the line having the equation 2x plus 3y equals 6. First, we will find the x-intercept. To do so, we plug in 0 for y. Doing the multiplication, we are left with 2x equals 6. Note that the y term drops out. We solve for x by dividing both sides of the equation by 2. Our x-intercept is 3. Now let's find the y-intercept. This time we will plug in 0 for x. Multiplying, we are left with 3y equals 6. Note that when finding the y-intercept, the x term disappears. Divide both sides of the equation by 3 to solve for y. Our y-intercept is 2. Plot the x-intercept and y-intercept. Connect our points. We finish by labeling the line. Let's see one more example. Suppose we have the equation 5x minus 2y equals 10, and we want to graph the line. We want to find the x-intercept. In order to find the x-intercept, we substitute 0 in for y. However, this simply makes the y term disappear. So we are left with 5x equals 10. Dividing, we find our x-intercept to be 2. Now we will find the y-intercept. Finding the y-intercept causes the x term to go away. We are left with negative 2y equals 10. Dividing, our y-intercept is negative 5. Plot the 2 points. Connect. Label. We need to have 2 points to graph a line. How we find those 2 points depends on which form the equation of the line is given. If we have the slope-intercept form, we are given the y-intercept. We then use the slope to find our next point. Move up and right, or down and left if the slope is positive. Move down and right, or up and left if the slope is negative. If we have the point-slope form, we need to determine exactly what point we are given. We then use the slope to find the second point. If our equation is given in standard form, we find the x-intercept by ignoring the y term and dividing. We find the y-intercept by ignoring the x term and dividing. Once we have the 2 points, we can connect the dots and label our graph.